Hello, Math 8 students. This is Open Up Resources, Unit 2, Lesson 3 and Lesson 4. We're going to be talking about dilations with and without a grid. To get started, we have this little activity. It says find and label a point C on the ray whose distance from A is twice the distance from B to A. That's quite a mouthful. What we're really saying is A and B are this far apart. I want you to figure out C, and C is going to be twice as far from A as B is. So the way that I would do this is I would take my index card or my ruler, it depends on what you prefer, and I would measure to see how long AB is and know that twice that amount, so doing that for a second time, is going to show me where point C is. I want you to understand what that really means. That means we have a dilation with A as the center, and the scale factor is 2. Write that down. Dilation, in which A is the center, and the scale factor is 2. Make the connections to what this warm-up seems to be asking and what it really truly is asking. What are we really doing? And with that in mind, we need to also figure out where point D is. It's going to be on this ray, and it's going to be distance that is half of what it is from A to B. Again, this is where your index card or ruler is going to come in handy. I don't have those tools available to me on the screen, so I would just see here's A to B, and if I were using my index card, I would then take that and I would fold it in half so that I would know where that next point is going to be. I'm going to eyeball it. I believe it's going to be right around there, and that's going to be D. Exactly half of an inch, so it printed off nicely that it was a nice measurement for you. Okay, and again, let's describe that. That really is saying we are dilating just that single point B with the center of A as a center of dilation, and the scale factor this time is half that distance, so the scale factor is 1/2. And now, before we dive into the official part of the lesson, there's a few things that we need to review. And that is, a dilation is a transformation that produces scaled copies. So this is kind of an interesting concept, that a dilation produces scaled copies. What is a scaled copy of a point? It still is another point. But notice what happened with this point B when it was dilated. The distance from that center of dilation is what changed. So when we dilated by a scale factor of 2, that distance from A was even further away, twice the distance. And when we dilated with the scale factor of 1/2, that distance from A was 1/2 the distance as it originally was. Angles are preserved. That means that they stay the same. Angle measures are preserved, they stay the same. Side lengths are scaled up or down. That means that they're not staying the same because they're either getting bigger or they're getting smaller, which means it produces non-congruent figures. In order to perform a dilation, we need a center of dilation and we need a scale factor, and those things are going to be coming up again today. So, here is your dilation obstacle course. Let me give you the directions and I'll work through the first one with you. And then the rest of it you're going to have to do on your own with your group. So eyes on the screen. I'll wait until I have eyes on the screen. Thank you. This is not a dot to dot. It is 9 different points. And again, each one of these little problems has a little bit of a different instruction, and you have to figure out which point or what number we're talking about. So we start by saying dilate B using scale factor of 5 and A as the center of dilation. So I see A is the center, so I'm going to mark that one red. B is the actual figure that I am trying to dilate, and it's just a point, which means that when it's dilated it's going to still be a point, but its distance from A is what's going to be different and what's going to change. So I want you to remember what this looks like. When I do a dilation, the center of dilation and the point and the new point are all going to lie on the same line. So I can see that A and B are on the same line. And when I'm dilating this, it's going to lie somewhere on that line. So do you see how I'm extending that line all the way to the very edge of that diagram? So that means that B, when it is dilated, is going to be somewhere on this ray. We just need to figure out where exactly. And so, as I read through this, I'm going to change the color here just a second so that we can really see everything that's going on. Okay. So somewhere on this ray, and it says we're going to use a scale factor of 5. That means here is the distance from A to B. But a scale factor of 5 means that distance is going to be multiplied by 5. So here's 1. That would be a distance of 2, or a scale factor of 2. This is a distance of 3, or a scale factor of 3. Here's my distance of 4, scale factor 4. And finally, we make it to a distance of 5, which would mean that scale factor is 5. So what is the point that represents the dilation scale factor 5? The point is I. And that's what you're going to be doing, working with your groups or online learners, pausing the video and working on your own. I want you to answer questions 2 through 7. Only when you have answered questions 2 through 7 do I want you to come back and finish watching the recording when we go over these. Please pause the video now. All right, let's continue. Using H as the center of dilation, dilate G so that its image is E. What is the scale factor? Before it gave us a scale factor and we use it to identify a point. This time we're working backwards. We're given the center, which is H, so I'm going to go ahead and mark that one again. Here's H, that's the center. G is the point in question. G is the one that we are trying to dilate. And we're dilating it so that it's E. So take a look at that. Once again, I'm going to set this up so I can see, look, there's the center, there's the point. Those are the possible points going on and on and on. And so we see that if this is G, let's just say that that is a unit of 1. I can even give it a little measurement here. And we're going all the way to E, which is all the way here. That is quite a bit further away from H than G is. So I need to figure out exactly how much further away. And that's when I use my little measuring. We see that it's 1, 2, 3 times away. I don't know why all of a sudden changed. 3 times as far as G is, which means the scale factor is 3. Question 3 is asking in reverse. Okay, what if E is that original point and we're dilating it so that it gets closer and closer and closer to H? So here's the distance of 3. Here is the distance of 1. Think about it. So G to E, we multiply by 3. Going backwards, E to G, we would multiply by that reciprocal 1/3. To dilate F so that its image is B, what point on the diagram can you use as the center? So this time we're making a connection between F and B. F and B are the point original and the point new. So I'm going to mark those ones again. I'm going to switch the color again this time. So F is the original, B is the new one. Notice that these points would lie on the same line as its center. So is D the center? How would D be the center if here's the original on one side and the new one is clear on the other side? Hint, it's not. There are more points that are on that line. You have to go all the way back to C. C would be the center of dilation with F being the original and B being the dilation, meaning it's getting smaller or closer to that center. So the correct answer, I don't even know what that point is called. Is it C? Yeah, C is the center. Dilate H using A as the center and a scale factor of 1/3. What point is its image? That's very similar to what I did below in green. Again, this time we have A to H is that far. And the question is asking, okay, what is the scale factor? No, the scale factor is 1/3. So what is the point that it becomes? Notice in the work that we've already done, do you see how we have our 1, 2, 3? So what is 1/3 of that going to be? There's 2/3. 1/3 is going to be all the way back here, point B. Describe a dilation that uses a labeled point as its center that would take F to H. So again, we're asking for that center. What would take F to H? And then notice we've already made some connections here. F and H are on the same line, if I extend that line, as E and G. So you have choices here. Is G going to be the center of dilation when they're on opposite sides? Or is it probably going to be E that's the center? Because E is going to have F, and then it's going to grow further away to H. So the center would be E. Oh, it says describe a dilation. We need more than that though, huh? Describe a dilation. Well, we would say the center is E. And the scale factor isn't there like what? Okay. Center is E. If I want F to go to G in a very similar way to what we observed before, this is 1, 2, 3 times the distance. So scale factor of 1, 2, 3 is what it would take in order to go from F to H. So scale factor of 3. And the last one, using B as the center of dilation, dilate H so that its image is itself. What scale factor did you use? Well, that would have to be a scale factor of, do you know it, Xander? Nope, it's asking what scale factor did you use. So it should be a number. Landis? What scale factor did you use? We already know that we're using B. H is, no, sorry, B is the center of dilation. H is the point we're trying to move, but H is going to itself. So what is the scale factor? Emily? Nope, because 2 would make it 2 times as far away. It would be in a different spot. Parker? It is a scale factor of 1. You have to understand whatever that distance is, it needs to stay the same distance from that dilation center point. The only way to do that is if we're multiplying by 1. Okay, I went in the wrong direction. Let me go this way. We had a conversation in my other class that I didn't have with you guys and that I didn't have with the online learners on a video. So we're going to have that discussion now. I need all eyes on the screen. You should probably even be writing this down. The same place where you wrote this stuff down is a great place to write down what I'm going to write down now. Here I have a star, and you guys do dilations a lot more often than you think. The first thing I'm going to do is I'm going to dilate this star so that it's bigger. Do you see how it's dilating? It's changing the size. All the angles are staying the same. I'm just going to move it on over here. Now I'm going to dilate it going this way. Again, notice the angles are the same. I can show that by matching and lining these things up, but I dilated it to be smaller. Now, the way that I've lined them up, I really want to try and figure out what is the center of dilation. And the way that I do that, I need to understand that when I dilate, let's just say that the center is back here. Then all of the vertices for the top of the star are all going to line up. And mine don't. I didn't quite get that last one in the right position. That is the center of dilation. And when I continue to try and line up these vertices, I'm going to now line up the bottom part here. going from the center to, whoa, maybe I need to do a little bit more work. Hang on 1 second. Unlock. I need to either move that one or make it smaller. There we go. Is that better? Okay. And I can continue doing that for every one of these vertices from the center. Now I'm going to go to this one. I'm going to extend that line, and what do you see? Goes through that one and that one. And we're not surprised by that because that's exactly how each of these figures is built. And that's what we did in our last one where we had a point, we drew that ray to figure out where it was going to go to. And that's exactly what we're doing. But in this very next problem, look, I'm going to go through this one now. Goes through all of them in the same spot. I don't give you the center, but we need to use this concept right here to figure out where that center is going to be. Okay, so let's work backwards then. Let's pretend like I did not give you that center of dilation. All I gave you is a couple of these figures. How are you going to figure out where that center of dilation is? Knowing that all of these vertices will form a line. With that center of dilation, I should extend that line all the way back. And the same thing would happen here. This and this, they're all corresponding points. And so all of those are going to be in a line, so I just continue that line all the way back until I find that center. So you can work backwards. That's what I'm doing now, is I'm working backwards to now go back and figure out where that center of dilation is. Lining up those corresponding points, extending it even further back to figure out that center. And now I can see exactly where that is again. There is the center of dilation. Use that to answer our next question. Here is line segment DE. Here is its image D prime E prime under a dilation. It says use a ruler. Find and draw the center of dilation. How are we going to do this? Quick discussion with your groups, because if you were paying attention to the stars, you would know exactly how to do this. Quick discussion, ready, set, go. Okay, and now this is what we should be doing. We should be using our ruler or our straight edge to draw from E to E prime and even further back, because I know that it's going to line up with the center of rotation or center of dilation wherever it is. And same thing with D and D prime. Those 2 points are going to line up with the center of rotation. Since I'm trying to find that, that's why I got to extend that line further back to see where that center of dilation would be. Here's where those 2 lines intersected. So here is the center, and it says we need to label it F. But I really want to drive this point home. Make sure that you also understand that F is the center of dilation. Label it center of dilation. Now, this is another quick discussion question. What is the scale factor of the dilation? Because remember, our dilations need a scale factor. So, what is that scale factor here? Quick discussion with your groups, another 15 seconds, go. And here is what I did to answer that question. I'm really ultimately trying to compare these lengths, right? And so I would say, okay, are these lengths? Let me infinite clone this so that I can see the comparison. You guys can actually use your measuring device. I'm just going to kind of line them up. There's 1, 2, 3, 4 of them that are all going to fit there. Looks like mine is a little bit better. So what is the scale factor? If this is 4 times as big as this, what's that scale factor? You weren't paying attention then. If you say it's 4, you're not paying attention. Which one is the original? the long one. So how does the long one become shorter? By multiplying by 4? Zeta? By 1/4. We don't divide. Scale factor is a number we multiply by. So if you see that 4 of them, and we can go 1 times 4, we use that information then to figure out, okay, what am I multiplying by to go this way, since that's the real way that I'm dilating. I'm shrinking it. That would be multiplying by 1/4, the reciprocal. Lesson 3 summary. If A is a center of dilation, how can we find a point? Let me start over. If A is a center of dilation, how can we find which point is the dilation of B with a scale factor of 2? Since the scale factor is larger than 1, the point must be further away from A than B is, which makes C the point we are looking for, because this is further away, which it should be because the scale factor was 2. That's larger than 1. If we measure the distance between A and C, we would find that it is exactly twice the distance between A and B. Again, that makes sense because it's a scale factor of 2. A dilation with scale factor less than 1 brings the point closer. This point D is the dilation of B with center A and scale factor 1/3 because it was closer. If we were to measure, this distance would be 1/3 of the distance between A and B. And now it's time for our cool down. Lynn drew a triangle and a dilation of the triangle with scale factor of 1/2. What is the center of dilation? Explain how you know. We've already answered questions like that, so you definitely have the tools you need to answer that question. Which triangle is the original and which triangle is the dilation? You have 30 seconds to discuss with your group. Ready, set, go. Okay, your time is up. What is the center of dilation? I hope that you noticed that C, D, and A all lie on the same line, just like B, E, and A all lie on the same line. So what is the center? A. So which triangle is the original and which one is the dilation? Landis? The original is ABC. How do you know that the original is ABC? Okay, but you have to be careful. There's extra information that's given to us, and it's right here. A scale factor of 1/2. 1/2 is less than 1. I'm glad you all thought that was funny, because I certainly didn't. Less than 1. Less than 1 means it is going to get smaller. So that would mean ABC is the bigger one, making it the original, because in order for it to get smaller, we would have to have that smaller triangle ADE or AED available to us. AED is the new one because it is the smaller triangle, and the scale factor of 1/2 means it's going to get smaller. And now we're ready for your practice problems. Yes, I do need you to complete all of these practice problems. No, it's your homework. This is how homework works. We do a lesson, then you do the homework, you have your practice problems. Remember how homework works? We do it at home. That's it for today. We'll see you next time.